During this video, I need you to go to Google Doc, go to the Google Drive, your Algebra 2 folder, and make sure you have this Graphing Linear Systems Intro PDF, and also have your calculator handy, your graphing calculator handy, so that later on I'm going to be giving you guys some examples of how to do your homework. All right. The other thing you're going to want to have is some blank white paper so that you can finish your homework on that. Here's the concept behind graphing linear systems. The solution to a system of linear equations is the value of the input that produces the same output for both equations at the same time. The intersection of the graphs of the two functions is the solution to the system. There are three possible situations for systems of two linear equations. The first situation, you're going to have two graphs that intersect and therefore have one solution. The next one is you're going to have two graphs that are parallel, no intersections, no solutions. And the third scenario is that you might have two functions that graph the same line, therefore there are infinitely many intersections, and therefore you have infinitely many solutions. Let's look at the first example where you have one intersection and one solution. Here we have a situation. Your family is going to rent a car on their vacation to New York. They have to decide which car to rent. The red car company rents cars for $30 a day and charges $2.50 per mile. The blue rental group will allow your family to rent a car for only $20 a day but charges $3 a mile. The dependent variable is the total cost to rent the car in dollars, and the independent variable is the distance your family drives while on vacation. Now, if you were to write an equation that represents the red car company charging and the blue rental group charging, then you would end up with the blue line and the red line, and if you graph them, they would intersect at the point 2080. The input of 20 produces the same output of 80 for both equations. This is the solution for the system, and in context this means that it will cost $80 from both the blue and red rental companies to rent a car and drive 20 miles. No intersections is the same as saying that there's no solutions. As I mentioned before, we're going to have two parallel lines. So let's look at the situation. This means that the blue rental company decided to lower their charges to $2.50 per mile. When the lines were graphed, they were parallel. They have the different intercepts, but the same slopes. No input would produce the same output for both functions, and therefore there are no intersections. The solutions, there would be none. And so we say that this system has no solutions. In this case, let's say that both companies charge the same amount per day and per mile. That would mean that they would have the same line that was graphed. And since every input produces the same output, then the two equations have infinitely many intersections. Therefore, the system would have infinitely many solutions.